move the object towards the mirror. That means this is the case of virtual object forming a virtual image. Concave mirror can form real image of real object. So hello everyone, a very warm welcome to LN Overseas, and I'm back with the series that is 45 topics in 45 days. In this series, we take 15 topics from each of the subject, summing up to 45, which is quite important for JEE Main. So today we are going to take a topic of physics, and that is the mirrors. So that is quite cliche topic. We know mirrors. Yeah, I know, I completely agree with that. But today we are going to take a new approach, right? Or the graphical approach. So after getting the graphs of the mirrors, you are going to understand all of the possible cases. All of the possible cases, right? So the confusion will be completely cleared after this approach. Are you ready? Let us start with a concave mirror, right? We will be talking about the spherical mirrors only. Okay. Suppose I have a concave mirror, right? We have a principal axis. Yeah. The first case is that when the object is at infinity, the image formed will be at the focus, the principal focus. Yeah. Okay. Next, move the object towards the mirror, right? When you are before the center of curvature, right? Before the center of curvature, the image formation will be between C and F. Yeah, diminished. You know the nature of image as well, right? We are not learning ray tracing here, right? Okay. So this is C, this is F. Then move it further. Now we are at C. Suppose we are at C. So image is of same size. It will be inverted, isn't it? Okay, and will be formed at the same exact point. Yeah, agreed, sir. Move it further between C and F. The image will move again further away. Yeah. Then at last at focus, the image formation is at infinity. We know that. Next, when you are between the pole and a focus, the image formation will be virtual in the opposite direction. Okay. Okay. Now before we directly dive into the graphical concept, let us first talk about sign convention a little bit, right? What we actually do in sign convention, we take the direction from where light is coming as positive x direction, right? Yeah. And the direction that is opposite to it with respect to the pole, that will be negative x. The upward one will be y, right? Or generally where the object is present, that is positive y, and the downwards is negative y, right? We know that thing. So all the quantities that are behind, that will be taken as positive, that will be on left hand side, that will be taken as negative, upwards positive, downwards negative, right? That is the general sign convention that we follow. Okay. That means if I am keeping object towards left, right? Suppose at 1 centimeter, so this will be taken as -1. Yeah. Suppose focus is at 3 centimeter, so I will be taking it as -3. Getting the gist? Yeah. Now, if I have to plot the graph between V and U, because that will tell us about every possible case. So these are the 6 cases that we generally learn, but they are not the only possible cases. You know why? Because these all are the cases of real object. But who said objects are only real? They could be virtual as well, right? Virtual object as in, so if image that is being formed by any other mirror or any other source is behind a mirror, so that image could act as virtual object for this mirror. Yeah. So virtual objects are quite basic things, right? We generally encounter them. So you are watching me, right? You are getting my image. So my image is a virtual image, right? And I am acting as a virtual object to you, right? I am not there in the real, isn't it? Absolutely. So we have something known as virtual object, right? Which do not exist. I am virtual object for you. Okay. So VU curve must include all the cases. So there will be some cases of virtual objects as well. So we have to consider that as well. So let us begin with the mirror formula. 1 by f is equals to 1 by v minus 1 by u. Plus 1 by u. So 1 by v is equals to 1 by f minus 1 by u, right? Or v will be equals to fu over u minus f. However, this is a concave mirror, and for concave mirror, the value of f must be taken as minus f, right? I cannot plot graph using this, right? In order to completely realize what is happening, we have to take it as minus f, so that this graph will be of concave mirror. Duh. So take it as minus f. So v will be equals to minus f u over u plus f. So we will be plotting the curve for this expression, right? How does this curve will look like? Something like this, right? And this curve is our agenda of the day, right? So here, this is a curve between u and v. Yeah. So u will tell you about the object, v will tell you about the image, right? Now if u is positive, that means the object is behind the mirror. The object is behind the mirror. And v is positive, that also means that object is behind the mirror. That means this is the case of virtual object forming a virtual image. Virtual object forming a virtual image. Yeah. Then that means if we move to the second quadrant, what will be the case? U will be negative. U negative means real object. V is positive, virtual image. Yeah. Move here. Here we have real object, U negative, and V negative, that means real image. Yeah. And here you have U positive, that is virtual object, right? And V negative, that means real image. Quadrants are clear, right? So if you have any point here, in UV curve, you are going to get virtual image of virtual object. But do you find any point in this case? No. That means it is quite clear for me, just by looking at the graph, that a concave mirror is never going to form a virtual image of virtual object. Getting the point? Will it form real? Will it form virtual image of real object? Yes. Will it form real image of real object? Yes. Will it form real image of virtual object? Yes. But a big no-no for virtual object, virtual image. So let us see the cases. So suppose object is at infinity. U is minus infinity, right? So V will be at minus f. U at minus infinity, V will be at minus f. Next case, between the object, the image formed is between minus f and 2f, minus 2f. Yeah, object is at, or object is beyond 2f, right? Beyond 2f, this is 2f, this is f, right? Next case, the 2f case. Yeah. Next case, when the object is between minus 2f and f, right, minus 2f and f, right, this is the object line, this is the image line, and image formation is beyond 2f, and lastly you have f and minus infinity, minus f and minus infinity. Yeah, quite clear. There is one more case that is remaining, that is between minus f and 0, right, between minus f and 0, right. So that means this is the case of virtual image obtained by real object. That implies, so it could be any of the point here, right, the last case. What about this case? This case is the real image formed by the virtual object. How will a virtual object look like? So for virtual object, the light will be converging behind the mirror, right, behind the mirror, somewhere here, right, but it cannot go behind the mirror in reality, right, it is mirror, it is going to reflect. So where it is going to go? There. Getting the point? So no matter what, if you have a virtual object, you are going to get a real image of that virtual object. Basic. No virtual image of virtual object. Can never happen. So that is why no point. Now this is a curve between V and U. There is one more important curve, and that important curve is of 1 by V versus 1 by U. This is easy. 1 by V is equals to 1 by F minus 1 by U, and for this concave mirror it is minus F, so minus 1 by F minus 1 by U. So this is Y is equals to minus mx minus C, right, or plus C which has a negative value. That means it is going to have intercept in the negative direction of the y-axis, right, but it will be a straight line, right. Let us see, a straight line with a negative intercept as promised. Again, for any positive u value, you are not going to get a positive v value. So again, there are no points here, right. Again, you have points in the second quadrant, in the third quadrant, and in the fourth quadrant, right. Nothing in first quadrant, right. Same, right. The quadrants represent the same exact thing, because if u is positive, 1 by u is positive. If v is positive, 1 by v is positive. Getting the gist? Yeah. So this is the curve. Looks something like this. Let us see all of the cases, right. F, right, object at infinity, right, beyond 2f, between minus 2f and f, and at f, after f, between p and minus f. All the cases are there. No rocket science. Here again you have virtual object and real image. Yeah, clear? So what's the conclusion from here? That concave mirror doesn't form virtual image of virtual object. Rest 3 cases, that is possible. Getting the point? Yeah, pretty much. Let us move to the sister mirror, that is the convex mirror, the opposite. Again, we have a convex mirror, right. This is the reflecting side, this is the polished side. You have a principal axis. Yeah. We have 2 cases for real object, right. Let us look at the 2 cases. When object is at finite distance, you have virtual image. When it is at infinite distance, you have a virtual image but at the focus. Yeah. Nice. What about the graph? Graph will be something like this. How? This is the case. From here 1 by V is equals to UF, right, or minus UF over U minus F, right? Sorry, V is equals to minus UF over U minus F. You are going to get this curve, right? Now in this curve, what you have? Again the 4 quadrants. What does this represent? Virtual image of virtual object, right? This is virtual image of real object, this is real image of real object, and this is virtual image, sorry, virtual object, real image, right? Real image of virtual object. Yeah. Okay. Now what? Look at this thing. The curve goes here. That means you have virtual image of virtual object, right? We will come back to this thing. In this quadrant, you have virtual image of real object. That is the general case that we have, right? That is the general case we have, isn't it? Here only, the 2 cases. You will have virtual object and real image. So for virtual object, you can have real image as well as virtual image. How? How? So suppose this is, if this is the focus, right? If light is coming like this and going on to the other side of the focus, right? Trying to go on to the other side of the focus, what is going to happen? It will reflect, right? Same thing. Light is coming here. So this is your virtual object. It will reflect and it is going to intersect somewhere here. So you have virtual image of virtual object. But what if they are trying to converge here? What if they are trying to converge here? Right? Before focus. If they are trying to converge before focus, you are going to get a real image of the virtual object. This is your virtual object, this is the real image. Getting the point? So it depends where your virtual object is kept. If it is beyond F or beyond F or before F, right? This is plus F, right? 1 by V and 1 by U curve look something like this. Duh, basic. So you have a virtual object and real image for that thing. Then you have virtual object and virtual image of that thing, right? When it is beyond F, right, on the right hand side of the F, the image formed is virtual. When it is before F, the image formed will be real. Getting the point? And the rest 2 cases are something like this, right? And like this. So see the color. For cream, you have virtual object, real image. Virtual object, real image. You have virtual object, virtual image. Yeah, you have virtual object, virtual image, the green one. Here you have real object, virtual image. Yeah, that is the general sense. These 2. Do you have real image of real object? Absolutely no. So convex mirror also have a case, right, where you are never going to find an image for an object, and that is the real image for real object. So it is never going to form a real image of real object. Getting the point? Right? So that's how the mirror works. And every case has been covered by these graphs only, right? Lastly, again a quick jog to your memory. Concave mirror can form real image of real object. Think. Virtual image of real object. Think. Real image of real object. Yeah. And virtual image of virtual object? Absolutely correct. Absolutely correct. So concave mirror cannot form virtual image of virtual object. Nothing in the third quadrant, remember? Yeah. And convex mirror can form real image of real object? Virtual image of real object? Real image of virtual object? Virtual image of virtual object? Yeah, you guessed it right. Right? So it cannot make real image of real object. So this is wrong. Rest everything is correct. Getting the point? That's how mirror works, and that's how you must remember the mirrors, right? Especially the spherical mirrors. So that is it for today, and I hope you have enjoyed this session with me. If you have any queries, any doubts, you can drop them in the comment box, and you can continue watching the playlist. The link is available in the description box. Bye bye and have a nice day ahead.